Hello and welcome to this video. Today we are going to be learning how to convert repeating decimals into fractions. The first thing we want to look at is what a repeating decimal is. So for part A, we have 0.3 repeating. That's the same thing as 0.3333 until we run out of space. To convert these types of numbers into fractions, we're going to use an algebraic trick. The first step is to say x equals your decimal, which is 0.3333. Usually 4 decimal places should be enough to do these problems. The second step is to do 10x equals whatever 10 times your decimal is. So we're basically moving our decimal place 1 to the right, giving us 3.3333. Now we subtract the top equation from the bottom equation. When we do that, you'll notice the repeating decimals cancel out. You have 33333 repeating, canceling, and that leaves you with a 3 is equal to, and then 10x minus x is 9x. Now we have to get x by itself. If you're not sure how to do this, we have a video talking about how to find unknown numbers in equations. Go ahead and check that out. For this problem, we take 9x equals 3, and we will divide both sides by 9. The 9's on the left side cancel, giving us x is equal to 3 over 9, which we can simplify to x equals 1 over 3. And that's our final answer for this repeating decimal. For part B, we have 0.1 with a repeating 6. Now you have to be careful because the repeating bar only applies to the 6. So if we rewrite this, this is 0.1 with trailing repeating 6's. Step 1 is going to be x equals whatever our decimal is. We'll write it out to 4 places. And then we will find 10x equals 1.6666. We will simplify this by subtracting the top and the bottom, leaving us with the trailing 6's canceling. We now have 6 minus 1, giving us 5, decimal. 1 minus 0 is 1, equals 9x. Now we have 9x equals 1.5. Now to solve for x, we will divide both sides by 9. Rewriting this, we have x equals 1.5 over 9. If you're not quite sure how to solve this, or this just looks different, you can try multiplying the top and the bottom by 10. What this does is essentially moves the decimal 1 place to the right, giving you 15 over 90. Now this should look like a fraction you're able to simplify. Let's divide the top and bottom by 5. That would give us x equals 3 over 18. We can simplify this one step further by dividing the top and bottom by 3, giving us our final answer of 1 over 6. For part C, we have 0.36 repeating, which can be rewritten as 0.3636. Step 1 remains the same. We're going to write x equals 0.3636. Now if we tried our previous step of taking 10x, that would give us 3.6363, and you notice the trailing fractions never cancel. So we don't want to do this. So we'll erase that. Instead, we will want to do 100x. That looks like 100x equals 36.3636. Now our trailing decimals line up perfectly to cancel when we do our subtraction problem. So as we simplify this, we will get 36 equals 99x. To solve for x, you divide by 99. Rewriting it, we have x equals 36 over 99. And we can reduce this by dividing the top and bottom by 9. And that will give us x equals 4 over 11, which is our final answer. Now, as a general rule of thumb, if you ever see these problems in the future, however many digits are in the repeating part is how many zeros will need to be in your multiplied factor. So for 0.36, you use 100. If it was 0.123, you would use 1,000, and 0.1234, you would use 10,000. For our final example, part D is going to be very similar to part A. Go ahead and take a moment to pause this video and give it a try. For the solution, step 1 is rewriting it as x equals 0.5555. And since there is only one digit repeating, we will take 10x equals 5.5555. We subtract the two values, leaving us with 9x is equal to 5, and the trailing 5s will cancel out with each other. Dividing by 9 on both sides gives us x equals 5 over 9. And that's our final answer. That's all we have for today. If you have any questions, feel free to leave them in the comments. Thanks for watching.